Good evening, Tilak. Good evening, Sahiti. Good evening, Charan Sai. So, what do you mean by a solution? It is a homogeneous mixture of two or more substances. Binary solution consists of only two components, solute and the solvent. The component which is present in the larger proportion is called as solvent, and the one which is present in the smaller proportion is called as solute. Four terms are used to express concentration, namely molarity, normality, molality, and mole fraction. Okay, now it's the time to discuss in detail about the multiple choice questions based upon the solutions. Hello students, welcome back to my live session, which is totally based upon the multiple choice questions based upon the solution. Here we go. So moving to the first question, the following compound readily forms a supersaturated solution. You try to identify the correct answer. Anyhow, I will read the options. Option A, sodium carbonate. Option B, sodium hydroxide. Option C, hypo. And option D, sodium bicarbonate. Share your answer. Yes, what is your answer? You just read the question properly. Which of the following compound readily forms a supersaturated solution? No? No one is giving the right answer. Two substances can form a supersaturated solution. What are they? Very good. Lalita Hack. They gave the right answer. Hypo will form a supersaturated solution and its formula is Na2H2O3, and the other compound which forms a supersaturated solution is sodium carbonate. Sorry, that is sodium acetate. Clear? CH3COONA. These two form supersaturated solution more readily. Clear? Moving to the second question. Sugar dissolves in water due to the formation of. So no doubt sugar dissolves in water. So due to what factor sugar is readily soluble in water? Very good. Charan Sai, Hack, Suhani, Leela, Sahiti, Sujit. They gave the right answer. Yes, very good. So, sugar is soluble in water due to the formation of hydrogen bonding. So, let us move on to the next question. The solvent in air is a gaseous mixture, isn't it? So, in that air, which one will act as the solvent? Are you ready to answer third question? Yes. The solvent in air is. Very good, Charan Sai. So, air is a gaseous mixture consisting of nitrogen, oxygen, carbon dioxide, hydrogen, helium, argon. But the major contributing gas is nitrogen. So, it will act as a solvent. So, in this case, option A, nitrogen is the right answer. Very good. Everyone is giving the right answer. Physical change among the following is. So, physical change among the following is. Anyhow, I will read the options. A. Burning of coal. B. Burning of sulfur. C. Dissolution of glucose in water. D. Burning of white phosphorus. What you are supposed to identify? Which of the following is a physical change? Yes, very good. Charan Sai, Hack, Suhani, they gave the right answer. Yes, dissolution of glucose in water is a physical change. Very good. Ma, each and everyone has to answer. Okay, let us move on to the next question. So, what is the fifth question? Homogeneous system among the following is. Which among the following is the homogeneous system? I will read the options. Option A, milk. B, sand in water. C, urea in water. D, benzene in water. So, homogeneous system means you are supposed to identify a solution. A solution that is homogeneous in nature, which maintains only one phase. When you put sand in water, what happens? You will observe water layer and also sand layer. In the similar way, when you put benzene in water, you also observe two distinct layers. So, between A and C, you have to identify the right answer. No one gave right answer. So, urea in water is a homogeneous system. So, option C is the right answer. Next, let us move to the sixth question. Accretion of hydrogen on palladium is an example of. So, accretion of hydrogen on palladium is an example for. Listen to me carefully. So, hydrogen on palladium is an example for. Option A, gas in solid. Option B, gas in liquid. Option C, solid in gas. Option D, liquid in gas. Sai, very good. What about the remaining students? You have to participate actively. It's your time. I am waiting for your answer. Abhilash, very good. Very good, Sai. Hack, very good. Yes, Lalita, very good. Leela, very good. So, hydrogen on palladium is good example for gas in solid system. So, option A is the right answer. It's very interesting. Seventh question is match the following. So, list A consists of gaseous solution, liquid solution, solid solution and colloidal solution. List 2 consists of German silver, milk, aqueous alcoholic solution. Fourth one is air. So, I will read list 2 once again. 1 is German silver. 2 is milk, 3 is aqueous alcoholic solution, 4 is air. You better identify the right matching. Yes. Good evening, Hemant. Ma, you try to identify the right matching. Yes, very good. Suhani, Tilak, Lalita, Sarath Kumar, very good. Leela Sai, Sai, Charan Sai, you gave the right answer, very good. So, gaseous solution means air is the gaseous solution. Aqueous alcoholic solution is the liquid solution. German silver is the solid solution. Milk is the colloidal solution. So, here the right option is A. A4, B3, C1, D2. So, what is the right option? Option A is the right answer. The units of molarity are. Yes, you have to identify the units of molarity. Very good. Each and every student gave the right answer. It's so nice. Yes, very good. Tilak, Abhilash, Lalita, Suhani. Very good. Each and everyone is giving the right answer. Too good. So, the unit of molarity is mole per liter, that is mole liter inverse. Too good. Let us move on to the next question. The equivalent weight of sulfuric acid is. So you are supposed to identify the equivalent weight of the sulfuric acid. As it's the time to answer 9th question. Charan Sai, here you are supposed to identify the equivalent weight of sulfuric acid. Charan Sai, very good. Leela, very good. So how to get the equivalent weight? Equivalent weight is equal to molecular weight by, here it is an acid, so we have to use basicity. So the number of replaceable hydrogen atoms. How many hydrogen atoms can be replaced? In the case of sulfuric acid, the formula of sulfuric acid is H2SO4 and its molecular weight is 98. Its basicity is 2, and hence what is the right answer? S. It's 49. So option A is the right answer. Clear? Ma, option A is the right answer. That is 49. So next, let me discuss about the 10th question. Each and every question is interesting and you just listen to me carefully. Coming to the 10th question, the number of glucose molecules present in 100 ml of decimolar solution. S. No. Anyhow, I will explain. No one is giving the right answer. Listen to me carefully. So, whenever if we consider a molar solution, it contains undoubtedly Avogadro number of particles. And here it is a decimolar solution. That means its molarity is 0.1. Then ultimately it contains 0.23 into 10 power 22 particles. So especially 1 molar or 0.1 molar means it is for 1 liter solution. So it is the first task. You have to identify how many particles are present in decimolar solution, that is 0.1 molar solution. And what is the second task? Here we have to consider only 100 ml of the solution. So 6.023 into 10 power 22 particles are present per 1 liter of the solution. So when you are supposed to identify how many particles are present for 100 ml means you just divide with 10. Then what happens? It is equal to 6.023 into 10 power 21. Now tell me what is the right answer. Yes, Leela, very good. Option B is the right answer. Here small logic will be there. You always remember 1 mole of any solution contains Avogadro number of particles. Avogadro number of particles means 6.023 into 10 power 23 particles. And you have to apply according to the given question. Okay. Here analytical skill is required. Let us move on to the 11th question. Similar type of question. I am waiting for your answer. Okay. I will wait for your answer. 100 ml of An aqueous solution contains 6.023 into 10 power 21 solute particles. So what is the given solution? 100 ml of a solution is given and that contains 6.023 into 10 power 21 solute molecules. The solution is diluted to 1 liter. So what is the second step? That is diluted to 1 liter. And the number of solute particles present in the 10 ml of the dilute solution is. Once again, I am reading the question for your convenience. Carefully listen to me. 100 ml of an aqueous solution contains. So, 100 ml of the solution contains 6.023 into 10 power 21 particles. Okay. And it is diluted to 1 liter. Next, 10 ml of the solution is taken and you are supposed to identify how many particles will be present. Everything is available, you just answer. Very good. Lalita, Kanya Reddy, Hack. Kanya Reddy, you both gave the right answer. Anyhow, I will explain in detail. So, initially 100 ml of the solution is taken that contains 6.023 into 10 power 21 particles. The solution is diluted to 1 liter. So, even then 100 ml solution is diluted to 1 liter. Still, it contains same number of the particles, isn't it? But here from that 1 liter solution, only 10 ml solution is taken. So, from 1 liter, we have taken only 10 ml of the solution. So, that's why you have to divide with 100. Only 10 ml solution is taken. Then what happens? It becomes 6.023 into 10 power 19. Very good. Charan Sai, very good. So, option B is the right answer. Simple logic. You have to catch that logic. Clear? Next, very simple and gunshot question. The units of molality are. Now you can answer. The units of molality are. It's, remember, molality. Molality. Very good. Charan Sai. Very good, Tilak. Yes, Lalita Sai. Sahiti. Very good. So, molality means the number of moles of solute present per 1 kg of solvent, and hence the units to express molarity are mole per kg. So, option B is the right answer. So, let us move on to the 13th question. Which of the following acid has same molecular weight and equivalent weight? Anyhow, I will repeat the question. Which of the following acid has the same molecular weight and equivalent weight? Option A, hypophosphorus acid. B, phosphorus acid. C, phosphoric acid. D, sulfuric acid. So, all are acids, and hence, if the basicity is equal to 1, then that acid will have same molecular weight and equivalent weight. So, for that purpose, I will explain the structures of A and B. Okay, you know the basicity of phosphoric acid. and also sulfuric acid. So for that purpose, I will explain only the structures of A and B. B is called as phosphorus acid. So its structure is P double bond O, hydrogen, OH, OH. You just remember carefully. Charan Sai, very good. You gave the right answer. Hydrogens which are directly attached to the oxygen can be replaced. So it is the structure of phosphorus acid, that is B. Coming to the structure of hypophosphorus acid, it is P double bond O, OH, H, H. How many hydrogens? Here we can replace only one. So the basicity of hypophosphorus acid, that is A, is 1, and hence it will have same molecular weight and equivalent weight. So option A is the right answer. Clear? Yes. Is it clear? Very good, Sai. Next one is a logical question. If the solubility increases with the temperature, then the change in enthalpy, delta H means the change in enthalpy of the solution is, you have to guess. As the solubility increases along with the temperature, how enthalpy changes, whether it is a negative quantity or a positive quantity, or it can be positive or negative or zero, you have to identify. I am waiting for your answer. Very good, Sai. What about the remaining students? Ma, you have to respond. Yes, Lalita, very good. Suhani, very good. So the change in enthalpy is a positive quantity. So option B is the right answer. You have to think logically, or you have to analyze the concept. It is too beautiful. 15th question is, at 25 degrees centigrade, at what temperature? At 25 degrees centigrade, molarity is equal to molality. So what is the first condition? At 25 degrees centigrade, molarity is equal to molality. Then at 50 degrees centigrade, what is the relationship between the molarity and molality? Is it clear? So at 25 degrees centigrade, molarity is equal to molality. And here the temperature has been increased. Then you have to identify what is the relation between molarity and molality. You have to think how molarity and molality will affect with the temperature. Then you will get the right answer. Yes. Undoubtedly, as the temperature increases, the molarity of the solution decreases. And coming to the molality, here both solute and solvent are present in the solid state. So temperature will have no effect. With the result, the value of molality is same, but the value of molarity decreases. So molarity is less than molality. So molarity is less than molality. Temperature will have no effect on the molality. It remains constant. But coming to the molarity, as the temperature increases, the molarity decreases. That's why molarity is less than molality at 50 degrees centigrade. Error. Moving to the 16th question. My screen visible to you? One of you answer. Screen visible to you? One of you answer. Screen visible to you? Sai? Voice audible to you? Yes, voice audible to you? Okay. Shall I continue? Very good. It's again a logical question. A mixture of salt and water can be separated by. So it is just like seawater. So a mixture of salt and water can be separated by which of the following techniques? Very good. Rajeshwari, Bhavani, Suhani, they gave the right answer. By crystallization, salt and water can be separated. Very good. Let me discuss about the 17th question. What is the equivalent weight of the Morse salt? If its gram molecular weight is 392. Here I would like to provide a hint. So Morse salt is ammonium ferrous sulfate. There Fe plus 2 will be oxidized to Fe plus 3 with the loss of 1 electron. Now you can guess. Listen to me carefully. With the loss of 1 electron, Fe plus 2 is oxidized to Fe plus 3. So now tell me what is the equivalent weight. Very good, Charan Sai. So gram molecular weight by loss of electrons gives the equivalent weight. So here only 1 electron is lost. So gram molecular weight by 1. Again it is equal to molecular weight. So option A is the right answer, that is 392. Very good, Sai, Leela. Very good. Coming to the 18th question. Lalita, very good. Rajeshwari, yes. The equivalent weight of KMnO4 in acidic medium. Here also I will provide a hint, that is the gram molecular weight of KMnO4 is 158, and in the acidic medium the Mn plus 2, Mn plus 7 is converted into Mn plus 2. So how many electrons are gained? 5 electrons. Now you calculate the equivalent weight. Everything is available. You just do the calculation. What is the gram molecular weight of KMnO4? 158. In acidic medium what happens? Mn plus 7 is converted into Mn plus 2. So how many electrons are gained? 5 electrons. So gram equivalent weight is equal to gram molecular weight divided by the number of electrons gained. What is your answer? Very good, Charan Sai. Tilak. You just to do 158 by 5. And then what is your answer? Sai, very good. Option A is the right answer. That is 31.6. Here again you have to answer for the logical question. As the temperature increases, you carefully listen to me. As the temperature increases, the vapor pressure of the liquid. What happens to the vapor pressure? As the temperature increases, what happens to the vapor pressure? Okay, no doubt at all, it increases. But there are two options with respect to increases. Increases linearly. C is increases exponentially. So there will be tremendous increase. The increase is pronounced, and hence the right option is very good, Leela, Lalita. So the increase in the vapor pressure is huge. So option C is the right answer. Very good, Sai, Lalita. Very good. Are you interested to do the calculations? Yes, here we go. 11.1 gram of calcium chloride is present in 100 ml of water. The chloride concentration is, it involves two parts. First, you find the concentration of calcium chloride solution and then move to the concentration of chloride. So I will provide one small hint. First, you calculate the molarity of calcium chloride solution. Then you can move to the concentration of chloride. Now tell me, what is the expression for calculating molarity? Weight by gram molecular weight into 1000 by V in ml. Substitute 11.1 divided by 111 into 1000 divided by 100. Here the molarity of the solution is 1 molar and you are supposed to calculate the chloride concentration. Listen to me carefully. The second part is very interesting. Calcium chloride dissociates into Ca plus 2 plus 2Cl minus. So 1 molecule of calcium chloride gives 2 molecules, otherwise 2 ions of Cl minus. So if the concentration of calcium chloride is 1, what is the concentration of chloride? Now you can guess. I will repeat once again. 1 molar solution of calcium chloride gives how many chloride ions? 1 molecule gives 2 chloride ions. So 1 mole gives 1 molecule gives 2 ions. Very good, Charan Sai. 1 mole gives 1 molecule gives 2 ions. So 1 mole gives 2 moles of chloride ions. It's so simple. Okay. Sarath, Lalita, Sahiti, very good. Option B is the right answer. Ma, you just try to follow whatever instructions I will give. So initially I will provide all the instructions. You just to follow them. Then you will get the right answer. Okay, too good. And next we will discuss about some simple questions. I think you will answer very quickly. An alloy is a homogeneous mixture of. What is an alloy? So coming to the options, it is a mixture of two solids or two liquids or two metals or two non-metals. Yes, Charan Sai, very good. You gave the right answer. What about the other students? Very good, Tilak. Sahiti, very good. Lalita, very good. Sarath Kumar, very nice. Okay. So definitely an alloy is supposed to contain at least one metal. So in the given options, option C, it is a mixture of two metals is the right answer. It is very interesting. In a saturated solution. What type of solution? We are considering a saturated solution. There exists an equilibrium between. For your convenience, I will read the options. Option A. An equilibrium exists between solvent and excess of solid. Option B. Solution and excess of solid. Solid and excess of solvent. Option D. Solid and excess of solution. Rajeshwari, that is not the right answer. You should be very particular about the given options. Hack, that is also wrong answer. Okay, I will explain in a simple manner. Okay, you have no idea about all the given options. In that context, it is a solution. So whenever if you see the solvent, you cross those options. So it is a solution. So we are not discussing about the pure solvent. So option A and C will be eliminated. Next we are having how many options? Only two options, B and D. Very good, Leela. So there is no question of excess of solution. No. Excess of solid will be present. Never excess of solution will be present. So that's why always there exists an equilibrium between solution and excess of solid. In other words, you can call it as solute. So remember, in a saturated solution, always there exists an equilibrium between the solution and excess of solid or excess of solute. So option B is the right answer. Clear? Let us move on to the next question. Which of the following does not depend upon the temperature? Yes, it's so simple. Gunshot question. Very good, Charan Sai. Very good, Leela. Each and everyone has to answer. Sai, very good. Very good. Molarity, formality, normality all depend upon the temperature. Mole fraction will not depend upon the temperature. So option D is the right answer. Yes, very good. Suhani. So when a saturated solution prepared at a high temperature, a saturated solution prepared at a high temperature, be careful while I am reading the question. When a saturated solution prepared at a higher temperature is cooled, then you will get very good. Charan Sai, too good. Yes, a saturated solution is cooled. Then you will get the super saturated solution. So option B is the right answer. Very good, Tilak. Coming to the next question. Which among the following is insoluble in water? Which among the following is insoluble in water? Very good, Charan Sai. Hack, very good. Suhani, very good. So benzene is an organic compound and it is insoluble in water. Very good. You do this problem. The normality of 2.3 molar sulfuric acid solution is, the normality of 2.3 molar sulfuric acid solution is. S. Give your answer. Tilak gave the right answer. Very good. Lalita, Suhani, very good. Now listen to me. What is the relation between the normality and molarity? Normality is equal to molarity into n factor. In the case of acid, we have to identify number of replaceable hydrogen atoms. So here we can replace two hydrogens. So the molarity is 2.3 into 2 and it is equal to 4.6, and hence the right answer is, very good Sai, option D is the right answer. Eight gram of a substance of molecular weight. So what is the weight of the substance? 8 gram. What is the molecular weight? 40. That is dissolved in 250 gram of water. What is the molality of the solution? You have to find out the molality of the solution. Question is very clear and it is direct question. You just to find the molality. No, you do the calculation carefully. No, Sai. Very good. Very good, Lalita. Very good, Sahiti. So anyhow, I will give the expression for calculating molality is equal to weight by gram molecular weight into 1000 by weight of the solvent in grams. That is equal to 8 by 40 into 1000 by 250. That is equal to 0.8 molar solution. So option B is the right answer. Ma, these are very simple questions. Clear? Hanish, are you following? Yes. Let us discuss one more simple question, that is the normality of a solution obtained by dissolving 5.3 gram of sodium carbonate in 1 liter solution. Very simple question. Hanish, you just do the calculation and give the right answer. Okay, no problem, Hanish. Thanks for joining the class. Ma, where are the remaining students? Are you calculating? Very good. Suhani. Leela Sai, very good. So anyhow, I will explain how to calculate the normality. So normality is equal to number of gram equivalents divided by volume of solution in liters. Okay, here how to get the number of gram equivalents? Weight by gram equivalent weight, and here 1 liter solution, you just do weight by gram equivalent weight calculation. 5.3 divided by gram equivalent weight is 53. Ma, what is your answer? You just check your answer. What is the right answer? Very good. Suhani. Remember, it is the 1 liter solution. So you just do weight by gram equivalent weight. So 0.1 normal is the right answer. So option B is the right answer. Clear? Very good. Let us move on to the next questions. The following solution has same normality and molarity. Which of the following solution is having the same normality and molarity? Now you can answer. Tilak, very good. You try to answer. Next question. The present question you try to answer. Yes. Which of the following solutions will have same normality and molarity? Very good. Tilak? Univalent substances will have same normality and molarity. So, for which the charge of cation equal to anion equal to 1. They will have same normality and molarity. So, sodium chloride will have same value for the normality and molarity. Very good. And one more simple question. 5 moles of a solute dissolved in 10 liter of solution. What is its molarity? Simple question. 5 moles of a solute dissolved in 10 liters of solution. What is its molarity? Molarity is equal to number of moles divided by volume of the solution in liters. So it is equal to 0.5 molar solution. So option C is the right answer. Clear? Very good. Sahiti, Sarath Kumar. Very good. Formation of a solution is a. So formation of a solution is a gunshot question, direct question. Physical change, chemical change, physical and chemical change or none. What is your answer? Ma, before answering, you just think logically and then answer. Formation of a solution. When you put salt in water, then what happens? It comes under a physical change or chemical change? No, formation of a solution is a physical change. So option A is the right answer. Don't forget to remember, okay? Sai, very good. One more logical question. Which of the following solutions? So, which following solutions contain, you should be very particular, less number of H plus ions per liter? Which of the following solutions contain less number of H plus ions per liter? Yes. It's logical question. You just think. One simple logic is there. No. Each and every solution is having the same concentration. Okay, anyhow, I will read the options. Option A, 0.1 molar sulfuric acid. Option B, 0.1 molar HCl. Option C, 0.1 molar nitric acid. Option D, 0.1 molar acetic acid. Hack, very good. Listen to me carefully. All these are strong acids. They dissociate completely. So they produce more number of H plus ions. Coming to the option D, it is acetic acid. It is a weak acid and it dissociates to the lesser extent and it gives only few number of H plus ions. So option D is the right answer. Suhani, very good. Next we will discuss about the next question. In which of the following cases, be careful, in which of the following cases molarity and normality is same for 1 liter of the solution respectively? So in all these options, two solutions are there. For the first solution, you better calculate molarity, and for the second solution, you calculate normality. Both will have same value. It is a liter solution. You better calculate for the molarity. You better calculate weight by gram, molecular weight, and for calculating normality, you better calculate weight by gram equivalent weight. Now tell me what is our answer. So I will explain one by one. For the first solution, 4 gram NaOH. So 4 by 40, 0.1 molarity. Option A. For the second solution, you have to calculate normality. Weight 36.5 divided by gram equivalent weight 36.5. It is one normal solution. So for these solutions, the value is not same. Coming to the option B, 4 gram in 40, 0.1 molar solution. And very good. Rajeshwari gave the right answer. For sulfuric acid, it is 4.9 divided by 49 and that is equal to 0.1 normal. Yes. For the second option, that is option B, both molarity and normality will have the same answer. So option B is the right answer. Clear? Very good, Sai. You have to put everything on the paper. Never do calculations in air. You just do calculations on paper. Simple question. 1 mole of any particles contain. So 1 mole of any substance contain. What is your answer? You have to respond for the present question. 1 mole of any substance contain. Suhani, be careful while answering. So, I will give indirect clue. People are giving different options. Why it is so? Are you not confident? Yes, Suhani gave the right answer. Avogadro number of particles. Avogadro number means 6.023. So it is 2 to allowed into 10 power 23 number of particles. You have to Look at the options very carefully. Molecular weight of sulfuric acid is. Now, what is the molecular weight of the sulfuric acid? You just add the atomic weights of each and every atom present in sulfuric acid. Very good. Rajeshwari gave the right answer. Suhani also gave the right answer. Very good. Yes, everyone is giving the right answer. It is 98. Option C is the right answer. Molarity of pure water is. Listen to me. For calculating the molarity, especially, we will consider 1 liter of the water. So the weight of the water, whether it is kg or liter, we consider both are one and the same. So 1000 by gram molecular weight is 18, and hence do the calculation and tell me the option. It's 1000 by 18. What is the right option? So molarity of pure water you are supposed to calculate. So you just do weight by gram molecular weight. So 1000 by 18 H2O. So its molecular weight is 18. So 1000 by 18. Who gave the right answer? Leela gave the right answer. 1000 by 18 is equal to 55.55. Very good. Next one is molar solution contains. Question is very clear. Molar solution. That means 1 molar solution contains. I will read all the options. Gram mole of solute, Avogadro number of particles, 1 mole of solute, all. What is your option? What is your answer? Very good. Lalita, Anita, Sahiti, Suhani, they gave the right answer. So 1 molar solution contains gram mole of solute, 1 mole of solute, or Avogadro number of particles. All the given options are right. So right option is option D. The number of moles is highest in. Is the question very clear? For each and every option, you have to calculate number of moles. How to calculate number of moles? Weight by gram molecular weight gives the number of moles. You just do the calculation and tell me the answer. What is the right option? You do the calculation and tell me the right answer. You put everything on paper. Just looking at you cannot answer. Just looking at the options you cannot answer. You do the calculation. Let us calculate one by one. For the first option, 32 by. What is the atomic weight of oxygen? Yes, again it is 32. So 1 mole. 14 gram of N2. 14 by 14. Are you doing the calculations? So 14 by 28, that is equal to 0.5 mole. Next, 64 divided by sulfur atomic weight is 32, O2 is 32, again 64, and it is equal to 1. And coming to 4 gram of H2, 4 by the gram molecular weight of hydrogen molecule is 2, and it is equal to 2. Now tell me what is the right answer. Everything is clear? Yes, option D is the right answer. That's why just simply looking at the options you cannot answer. You just calculate and then answer. Volume of water required to convert 100 ml of 0.1 molar solution to 0.05 molar solution. You do the calculation. So initial molarity is equal to 0.1 molar. Initial volume is equal to 100. Final molarity is equal to 0.05. You calculate V2 value and finally you find V2 minus V1. That gives the volume of water to be added. Now tell me how to calculate V2. So V2 is equal to M1 V1 by M2. That is equal to 0.1 into 100 divided by 0.05. So that is equal to 200 ml. So 200 minus 100, that is equal to 100. So what is the right answer? Yes, you can give the answer. Now you will give the answer. Okay, option C is the right answer. Next, moving to the next question. Okay, the volume of 0.1 molar NaOH solution required to neutralize 500 ml of 0.5 molar sulfuric acid. Remember, it is an acid-base titration. Okay, what is the data of an acid? Here the acid is sulfuric acid and the base is NaOH. So, volume of NaOH you are supposed to calculate. The molarity of NaOH is 0.1. Molarity of acid is 0.5 molar. Volume is 500 ml. And here you have to use the expression M1 V1 by N1 equal to M2 V2 by N2. Okay. And we are supposed to calculate V2. For knowing N1 and N2, we have to write the principle H2SO4 plus NaOH gives rise to Na2SO4, okay, plus 2H2O. So the number of moles of base N2 equal to 2, N1 equal to 1. So coming to the expression for V2, M1 V1 by N1 into N2 by M2. That is equal to 0.5 into 500 divided by 1 into 2 divided by 0.1. So what is your answer? 5 times. 10 into 500. What is your answer? At least now tell me what is the right answer. Very good. So 5 to 10. 10 into 500, that is equal to 5 liters. Option C is the right answer. Very good. Let us move on to the next question. The normality of 0.98% sulfuric acid is. Very good. Everyone gave the right answer. Okay. Next, try to answer the present question. The normality of 0.98% sulfuric acid solution is. 0.98% sulfuric acid means 0.98 grams of sulfuric acid is present in 100 ml of the solution. So you better identify how much weight is present in 1 liter. It makes calculations easy. So that means 9.8 gram is present per 1 liter. So if it is 1 liter solution, simply normality is equal to weight by gram equivalent weight. So 9.8 divided by 49. Now tell me what is your answer. Now you can tell me what is your answer. Nine point eight divided by 49 is equal to how much? Yes, very good. 0.2. So the right option is 0.2 normal solution. Clear? Hack, Sarath Kumar, Leela. Very good. Now everyone is giving the right option. Few more bits to conclude. Which of the following solution is more concentrated? I will read the given options. Option A 0.3% phosphoric acid. B 0.3 molar phosphoric acid. Option C 0.3 normal phosphoric acid. Option D 0.6 normal phosphoric acid. In this case, one is given in terms of molarity, other one is given in terms of normality, and other one is given in terms of percentage. You better calculate the normality of each and every solution, then you will identify which one is more concentrated solution. Okay. So 0.3 phosphoric acid means 3 grams is present in 1 liter. Okay. 3 by the gram molecular weight of phosphoric acid is 98. Okay. And it is 0.3 molar solution. So you just convert it into normal solution. It is phosphoric acid. N factor is 3. and hence it is 0.6 normal solution. It is 0.3 normal solution. 0.9 normal solution, and the option D is 0.6 normal solution. Here also you have to use, it is the molarity, and you have to convert into normality, that is equal to 0.09 normal solution. Now tell me, which of the following solutions will have more concentration? Very good. Suhani gave the right answer. Rajeshwari gave the right answer. Yes, option B will have high concentration. If different concentration terms are used, you have to convert them into one term. You better convert them into normality terms, then you will find the right answer. Clear? Suhani, very good. Next one. 6 gram of urea is dissolved in 90 gram of water. The mole fraction of the solute is, you have to calculate the mole fraction of the solute. Ma, will you calculate the mole fraction? The gram molecular weight of urea is 60. So you first find the number of moles of urea. So N1 is equal to atomic weight by gram molecular weight, 0.1. Coming to the water, 90 by 18, that is equal to 5. So mole fraction of urea is equal to N1 by N1 plus N2, that is equal to 0.1 divided by 0.1 plus 5. 0.1 divided by 5.1. So that is equal to, yes, it's very simple, 1 divided by 51. So what is your answer? Yes, option C, 1 divided by 51 is the mole fraction of urea. Very good, Suhani. Leela, Sai, very good. Coming to the next question. Molarity of 1 molar aqueous NaOH solution is, and the density of the solution is given as 1.02 gram per mole. Here we have to know the relation between molarity and molality. In this question, the molality is given and you are supposed to calculate molarity, and also density is given. So here we have to use the expression molarity is equal to 1000 into density divided by 1000 by molality plus gram molecular weight. You just substitute the values. 1000 into what is the density of the solution, 1.02, divided by 1000 divided by molality. Here the molality of the solution is 1, plus what is the gram molecular weight of the substance, it is NaOH, hence it is equal to 40. So that is equal to, you just multiply 1020 divided by, here it is 1000 plus 40, 1040. So 1020 divided by 1040, yes, it will be approximately 0.98. So option D is the right answer. Clear? Is it clear? Okay. Anyhow, let us move on to the next question. how many grams of anhydrous? It is anhydrous oxalic acid is required to prepare 1 liter of 0.1 normal oxalic acid. So actually the gram molecular weight of oxalic acid is 126. It is anhydrous, so we have to remove the water and it will become 90. So the gram molecular weight of anhydrous oxalic acid is 90. So we have to prepare 1 liter solution having the normality 0.1. Then we have to calculate how many grams is required. I will give simple logic. So gram molecular weight is 90. So to prepare 0.1 normal solution means here we have to calculate equivalent weight. So the equivalent weight is equal to exactly half. So 90 by 2, that is 45. So 45 grams of oxalic acid is required to prepare 1 liter solution. So in order to prepare 0.1 normal solution, we require only 4.5 grams. So that's why option C is the right answer, 4.5 grams. So in this way we can do calculation very easily through the logic. Okay. Gram equivalent weight is equal to gram molecular weight by 2. So for anhydrous oxalic acid, equivalent weight is 45 grams. That means 45 grams of oxalic acid is required to prepare 1 normal solution in 1 liter. So for the preparation of 0.1 normal, we require only 4.5 gram. Very good. Suhani, very good. Next one is, here also you have to follow the logic. If the sulfate ion concentration in a solution of aluminum sulfate is, so the sulfate ion concentration is 0.25 molar. The concentration of aluminum sulfate is, no need of doing all the calculations, you just follow the simple logic. So whenever if we consider aluminum sulfate, it dissociates into aluminum and gives sulfate ions. So 1 aluminum sulfate gives 3 sulfate ions. Here the concentration of sulfate is given, that is 0.25 molar, and we are supposed to calculate the concentration of aluminum sulfate. What we are supposed to do? You just divide with 3. What is the right answer? Is the logic is clear? Aluminum sulfate dissociates into aluminum ions and sulfate ions. If you take one molecule, it gives 3 ions. So the 3 ions concentration they have given, and we are supposed to calculate the concentration of one molecule. So you just divide with 3. Yes, very good. It is equal to 0.0833 molar. So very good. Option C is the right answer. Leela Sai gave the right answer. Very good. One simple question. When phenol and water are mixed together, when phenol and water are mixed together, just a few minutes to conclude the class, it results in homogeneous system. That means homogeneous solution or heterogeneous solution or colloidal solution or none. Here you must know the formula of phenol. Benzene having OH group, water H2O. What is the logic? Phenol is soluble in water due to hydrogen bonding. Then what happens? Phenol is completely soluble in water because it consists of OH group. Hydrogen bonding is possible. Then what type of system will be obtained when phenol is mixed with water? Bhavani, you just think and answer. It is completely miscible. That means it gives a homogeneous solution. So option A is the right answer. Yes. Coming to the next question. From the following, choose the correct H plus ion of a NaOH solution in molar if its pOH is 11.3. Okay, anyhow, I will explain this question. So, pOH of the NaOH solution is given and you are supposed to calculate the H plus ion concentration. Now, listen to me carefully. So, for NaOH solution, they have given pOH. So, if you know pH, then it is easy to calculate H plus ion concentration. We know that pH plus pOH is equal to 14. So, pH is equal to 14 minus pOH. So, that is equal to 14 minus 11.3. So, that is equal to 2.7. It is the pH of NaOH solution. S. Coming to the H plus ion concentration, that is equal to 10 power minus pH. So, that is equal to 10 power minus 2.7. So, we cannot calculate in negative values. So, it can be written as minus 2.7 can be written as 10 power minus 3 into 10 power 0.3. So you just find the anti-log of 0.3. That may be around 1.998 into 10 power minus 3. So this value is very close to option A. 2 into 10 power minus 3 is the right answer. Clear? You have to analyze the concept in that way. So pOH of the NaOH solution is given. Then you have to calculate first pH. Then you can calculate H plus ion concentration. Next one. A sample of H2O2 is used for bleaching hair. It contains 51 gram of H2O2 in 90 gram of water. Find the mole fraction of water. You can do this calculation. Yes. Number of moles of H2O2 equal to 5.1 divided by 51, that is equal to 0.1. Next. Yes. Sorry, you just calculate the gram molecular weight of hydrogen peroxide. It is 34. Now do the calculation. You just do the calculation. So what is the gram molecular weight of H2O2? 34. In that context, it is equal to 0.15. And the number of moles of water equal to? Yes, 90 divided by 18, that is equal to 5. So what is the mole fraction of H2O2? 0.15 divided by 0.15 plus 5. So that is equal to 0.15 divided by 5.15. Now tell me what is the right answer. Very good. Suhani, Rajeshwari, they gave the right answer. What about the remaining students? Very good. Last question to conclude the class. In which of the following solution the quantity of solute is more than solubility? If you answer this question, I will be happy. In which of the following solution the quantity of solute is more than solubility? You people are giving all the options. I want the right option. More than solubility. You should be very specific to the term. What is the right answer? More than solubility. So, saturated solution contains maximum amount of soluble solute. More than solubility means it is a super saturated solution. So, option D is the right answer. If you like the live class, don't forget to like, share and subscribe. Thanks for watching. Have a nice day.